Okay, so today we're going to be talking about section 9.2, and 9.2 would be talking about angles and arcs. And I think the thing is that as we're talking about circles, we're familiar with the circumference of a circle is pi d, and so that would be the length around the circle if you would walk around it in inches or feet or whatever, and then the area inside of it. And we're going to focus today mostly on the arc length, or the length around of a circle. So if you walk all the way around a circle, it would be pi d. Okay, that would be how you would find the length around a circle. And so now the truth is, we don't always go all the way around a circle. Maybe we'll go twice, or maybe we'll just go a fractional portion around the circle. Okay, and so, and if you think about it, there are multiple ways to talk about how you would go around a circle. Okay, so the first thing is on side 2, we're going to actually find the length, okay, that you would go if you walked between A and C. So that would be an arc length. And so if you want to say, okay, how long would it be as if you walked from here to here in feet? If you run a race in track, if you go partway around the track, you might be running the 100, or you might run the 200, you might run 400 would be all the way around once, and then you sometimes go around all the way a couple times. So, that's kind of the length that you would run. So arc length is going to be in terms of feet and inches and stuff like that. But another way to talk about how far you went, and this is kind of an awkward way to think, would be in terms of if you're standing in the middle of a circle, how many degrees did you run of the circle? Again, if you go all the way around, it would be 360 degrees. And so you're like, that's just weird. Yeah, it is a weird, but you can think about it. If you're standing in the middle of the track, if you run 20 degrees between your arms, you would go, that would be a valid distance for someone to travel. Again, it's from the perspective of the center of the circle, how many degrees you would go. So it's true. It's not really the length, but it's the measurement in degrees of how far you went compared to somebody standing in the middle of the circle. Okay, so again, let's talk about it from that perspective. Again, it's weird, but it is how people talk. Okay, so a central angle would be the angle that's formed if you have a vertex in the center of the circle. So ABC is a central angle. So this is a central angle right here. So B is in the center, the vertex is in the center, and it's a certain number of degrees. And so an arc, okay, would be an unbroken part of the circle that is formed by an endpoint A and all the points in between, endpoints A and C and every point in between them. Okay, so that would be an arc right here. And if you go all the way around, that would be the circumference of the circle. So a partial, a part of that would be an arc. And so, and then there's more words here. So AC is also talked about an intercepted arc, because think about this. If you're cutting a piece of pie, you intercept a circle with the knife, on both sides of your piece of your pie. And so your angle is that interceptor, okay, that chops up the piece of that crust. So this angle right here, angle ABC, the ray AB and segment BC, I guess those would be segments, intercept that piece of the pie that you're going to take out. Okay, and so the arc is from A to C, and it can be called an intercepted arc because that's how you form it, is by cutting basically AB to be NBC, and that would be the arc between those two, the portion of that circle. And so you can have a minor arc and okay, so the definition is the points in between two letters. Okay, so the points on a circle, okay, between those. And so that would be an arc. And so I don't know why on my video these little arc symbols didn't show. So if we're saying, what is the measure of arc AC? Okay, so that's on your notes. You should see it. The measure of arc AC, what they mean is if you were standing in the center, okay, from the central angle's perspective, how many degrees is that arc of the 360 that are there? So the measurement is in degrees. And so the measurement of a minor arc actually equals the value of the the central angle. Okay, so the measure of a minor arc is equal to the measure of its central angle. Okay, and so that'll be the shorter distance, like the distance between A and C. So from A to C, the shorter distance is the minor arc AC. Okay, and so that's what we mean. If I just give you two letters, it's the shortest distance between those 2 points. And so if I say, what is the measure? I mean, from the central angle's perspective, how many degrees is that that arc going to be? And so we're not looking at a length. I'll ask you the length on the backside of these notes, but I'm just saying, what is the measure of it? And so that means from the central angle's perspective, how many degrees of the 360 is it going to be? And so the major arc is still could talk about AC, but if they want you to go the long way around the circle from A to C, they'll give a middle letter, be like, go from A to C through point D. And so that would be a major arc. So this is going to be less than 180 degrees. This is going to be greater than 180 degrees. Okay, so it's a long way around the circle would be the major arc. And so, and we can look at this. And since we know 360 is all the way around, it would be, you would take what 360 subtract off the smaller angle, the central angle. And so you can see what they're asking us to find. Again, when I ask you for the measure of an arc, I'm looking for how many degrees from the central angle's perspective is your arc going to be. Okay, not the length. If I want the length, I'll tell you I want the length. Okay, and so a semicircle is going to be simply halfway around a circle. So how many degrees is halfway around a circle? Well, that's always equal to 180 degrees. Okay, so, and again, this should have an arc on it. It doesn't, because you need to know if it's a shape, you need to know what shape it is. So the measure of any halfway around a circle, of course, is going to be 360 divided by 2, or 180 degrees. Okay, and so we've got 3 kinds of arcs that we're going to talk about. The minor arc, which is the shorter distance around the circle between those 2 points. The major arc, which will be bigger, it's the longer distance between those points by way of the point they tell you in the middle. And you can find it, since all the way around the circle is 360, you can subtract the minor arc, or the central angle, from 360 to get that longer distance. And then we can also say that because we're dealing with numbers, we can say the arc addition postulate is if you add up 2 arcs, you'll get the overall length between those 2 arcs. And so if you want to say what is, again, they should have little arches on that. So let's try these. So the measure of this thing equals the measure from here to here plus this measure right here. And so if you add up from here to here's degrees plus here to here's degrees, you'll get the overall number of degrees that you want. So the measure of AC is equal to the sum of those 2 angles. So we can practice this. We'll practice this in a little bit too. Okay. So let's practice here. If you've got this, what is the measure? And every single one of these has an arc on it on your notes. Okay. And they're saying from the central angle's perspective, how many degrees of the 360 did you go if you go from point A to point B? Okay. And they tell you that A and B is 90 degrees. They tell you that EMD is going to be 35 degrees. Okay, those are the central angles they give you them. We can go ahead and say, okay, these are vertical angles here, so this will be 35 degrees as well. And then also you can see that it's a straight line from B to D. That's a diameter. And so therefore, if you do 180 subtract 90 and 35, you're going to get the measure of this one to be let me do this real quickly. Okay, so that means that this will be 55 degrees right there. Okay, 55. Okay, I just took 180 minus 35 and 90, and so that'd be 55 degrees there. Okay, so what is the measure from A to B? Well, if the central angle is 90 degrees, well, then this arc is going to be, the measure of that arc will be 90 degrees of the circle. Okay, And then from A to D to B, so A to D to B would be 360 minus 90. Okay, so again, all the way around the circle from here all the way over to here would be 360 minus 90. That'd be 270 degrees. Okay, so the measure of that arc would be 270 degrees of the whole circle. Okay, BC would be 35 degrees. Again, vertical angles are true still. So A to D would also be 90 degrees. BCD, so from B to C to D, that's 180 degrees. Okay, that'd be a semicircle. And then C to D to E, C to D to E would be here. And that would be 180 degrees as well. Okay, so if we are going to be talking about the measure of A to C, okay. Okay, so as we do this, what the measure of AC would be, again, they're talking about the shortest distance because they don't give us 3 letters. It's going to be the minor arc they're asking us to find. Okay, so if I ask you what the measure of that arc is, again, from the perspective of the middle, from the central angle, how many degrees would that arc be? And so it would be 90 degrees. Okay, now what we have to do is find the length of it. Okay, so the length of it is going to be actually if you would walk around it, if the radius is 10 centimeters, how many centimeters would you travel if you went on the circle to walk from A to C? Okay, and so that is going to be 90 degrees out of the whole circle, right? So that's a fourth of the whole circle, right? And so you could do, compared to the distance all the way around, well, all the way around is pi d. So you could do 20 pi, and it's a fourth of that, okay? Or you could do 90 out of all the way around is 360. So we can find the product. So we're going to use our calculator. So when we use our calculator, it's going to ask you for in exact form and decimal form. So exact form, you're going to use your calculator and do 90 over 260 and just times it by 20. So just the numbers and put that in front of pi. Don't put the pi in your calculator because it'll make it into a decimal and make it approximately. So take 90 over 360 times 20 and you're going to get 5, okay? And it's going to be 5 pi, and that's going to be how many centimeters you would go. And if you want to do 5 times pi in your calculator, that would be approximately, I'm going to get my calc out here. 5 pi is going to be, use the pi key, is going to be approximately 15.71, okay? Okay, so you do a fraction of, what fraction of the whole circle, the distance around the circle did you go? Okay, so what would be a formula? So if you have m degrees, okay, out of 360, okay, what fraction are you trying to figure out the length of the pi d? And so to figure out the answer, you are going to multiply that together and be like, that's the fraction of the entire circumference that you actually did. So if you want the length, the measure is just the degrees. You're like, oh, it's just m. You know, like if it's 40 degrees or 100 degrees, it's just 100 degrees. But that's one way to say from the center, you're like saying, I went 100 degrees around the whole circle, okay, compared to 360. Okay, that's true, but not a length. Okay, if you want to find the actual length, you're like, well, in meters or inches or how far did you run? You know, I ran 20 degrees. Awesome. Of what kind of circle? And so we really want to say the length is going to be how far actually you went. Okay. And so we'll practice that at the bottom. Before we do that though, is saying, okay, look at this circle. So you've got graphs with percentages on it. And so like, well, how many degrees would it be? And I think that would be something where we convert using our stuff from last year, last chapter, be like, okay, we want to find the measure of arc BC. So we want to figure out how many degrees that is. So from B to C. And so if that's 13 degrees, the sucker thing is like, yeah, 13% is 13 degrees. No, percent is out of 100. So if we go 13 out of 100, okay, that's in percent, that equals X out of 360 degrees. And if we cross multiply and figure out, okay, how many degrees would that be? Because the measure of BC is in degrees, you're going to get 46.8 degrees. Okay, so that's going to be a good thing. It's like if you're converting a percent to degrees, well, 13%, 13 out of 100 equals X out of 360. So that would be a good thing for you to hold on to too. Okay, so let's practice that formula that we came up with at the beginning. Okay, so they're saying find the length from G to F. Okay, so they're saying this is 134 degrees. So 134 degrees is the measure. Okay, so we want to find the length of it. Okay, so 134 out of 360. That's what fraction of the circle you did. Okay, and that fraction of the entire circumference is what we want to find the actual length. And so equal or times it by the whole distance. So that fraction of the entire circumference, and that would be 16 pi. And so the first way we do it is going to be exact. So we take 134 over 360 and just times it by just 16. Okay. So if you do that in your calculator, you're going to get 268 over 45, and that's going to be times pi. And that's going to be the exact form for how many centimeters you traveled. Okay. The approximate is to put that in your calculator and then just times it by the pi key, and you're going to get 18.71. centimeters. So I want you to be able to be comfortable saying, to find the length, I can find the exact in terms of pi, where you just multiply the numbers and put them in front of pi. Use the fraction key, keep your answer in a fraction. And the second thing is you take that fraction times the pi key and you'll get your approximate answer. Okay, the last thing we're going to do would be just another practice. Okay, if you're saying I went around 62 degrees of a circle, well, how far did you actually go? Well, 62 out of 360 is how far I went. I went part of the circle, about a sixth of the circle, and you times it by the distance around a whole circle, which is going to be pi d. So it'd be 4 pi. And to get the answers, the first one you just times the numbers in your calculator, and you're going to get 31 over 45. And that's pi, and that's going to be in meters. And then if you just times those two values together using the pi key, you're going to get approximately 2.16. And that's meters. Okay, so we've got the two answers. And you can put them in these blanks. So the first one would go in the first one, the approximately would go in the second one. Okay, well, thank you so much. Have a good day.